These are the chapter 6.5 notes, trigonometric functions of general angles. This is page 7. So we are going to bounce around a little bit on this page. I have reorganized as I wrote these notes. So pick the part that makes the most sense to you. When we talk about a unit circle, unit anything means 1. So in a unit circle, the radius is 1. Okay. When we use the definition of the 6 trig functions, which I have included right here, we can figure out what this looks like in terms of the unit circle. Now, that is not the circle to the left. We're going to get to that in a minute. This is the circle at the bottom, unit circle definition. So, as I did on the last page, we can consider a point on that terminal side 1 away from the origin. So here my unit circle, that radius is always going to be 1. The sine of theta, and when we talk about theta, theta is our reference angle, is opposite over hypotenuse, so y over 1. Our cosecant then is the reciprocal of that, 1 over y. My cosine, and honestly we don't use cosecant and secant a whole lot, but you need to know that relationship. My cosine adjacent over hypotenuse, x over 1. So my secant is 1 over x. My tangent, opposite over adjacent, tangent will always be y over x. And cotangent is x over y. And I've used some of those relationships finding tangent in the past couple of pages. Okay. That means for any right triangle that we build in that unit circle, and we can extend that out because these are ratios, when we find that point on the terminal side here, my x-coordinate is always the cosine of theta. My y is always the sine. Hopefully, here the box to the right, these are starting to look familiar. Sine of 45 degrees, 45, 45, 90, we always have that relationship. Each of the sides is square root of 2 over 2. Cosine of 30, we're going to draw the triangles into the unit circle, and hopefully it makes more sense what these patterns look like. But cosine of 30, adjacent over hypotenuse, square root of 3 over 2, all over 1. The sine of 4 pi over 3. Again, 4 pi over 3 is going to land in that third quadrant. I know my sine is going to be negative. And I know for that pi over 3 family, my sine is the longer side. So I get negative square root of 3 over 2. Cosine of 11 pi over 6, that lands us in quadrant 4. Cosine is positive. And in that pi over 6 family, our cosine is square root of 3 over 2. Sine of pi, and this is where it gets a little tricky. The one thing that we haven't talked about a whole lot is the fact that if this is a unit circle, I can label these points that fall on the axes. My 0 degree angle or 360 all the way around are going to have coordinates 1, 0. My 90 degree angle here, I'm at 0, 1. My 180 degree angle, I'm at negative 1, 0. And my 270 degree angle, I'm at 0, negative 1. Sine of pi, right here. Again, we said cosine is the first angle, or sorry, the first coordinate, sine is the second. So the sine of pi is 0, and our pi over 2, our 90 degree angle, we'll label that here. cosine is that first coordinate, so my cosine is 0. Okay, now using that exact same thinking, I'm going to go back up to this right side where we have a circle where the radius is not 1. Ratios are going to be same between the sides, but if we're not in the unit circle, we may have a radius that's different. Sine is opposite over hypotenuse, so I get y over r. Cosecant is the reciprocal of that, so r over y. My cosine adjacent over hypotenuse, so x over r. Secant is the reciprocal of that, so r over x. Our tangent, opposite over adjacent, we got y over x. And our cotangent is the reciprocal of that, x over y.